Great morning, senior high school students of Valenzuela City. Welcome to Valenzuela Live, Facebook live streaming in General Mathematics. We are in quarter 1, week 2. I am glad to be with you today. Come and join me in today's session as we explore the key concepts of rational functions. Are you ready? Let's start. At the end of this session, you are expected to meet our today's objectives, which are represents real-life situation using rational functions, distinguishes rational function, rational equation, and rational inequality, solve rational equations and inequalities. Number 4, represent a rational function through its table of values, graphs, equation. And lastly, number 5, find the domain and range of rational function. In order for us to meet our today's objective, let us recall the concepts of rational expressions. What are rational expressions? These are ratio of two polynomial expressions in the form of p of x over q of x, wherein p of x is the numerator and the q of x is the denominator. Take note of this, that q of x should not be equal to 0. To warm up our today's lesson, let us have this activity. The answer drop. Okay, perform the operations in the following question which are related to rational expressions. Drop your answer in the comment box. I will give you 10 seconds to drop your answers. Are you ready? Let's start. Number 1. What is the value of the expression 2x plus 5 over 3 when x is equal to 2? These are the choices. Letter A, 3. B, 20. C, 27. Letter D, 4. 10 seconds. Go! Time's up. Drop your answers. The correct answer is A. Let's have question number 2. What operation is to be used when the expression consists of parentheses? These are the choices. A, addition. B, subtraction. C, multiplication. Or letter D, division. 5 seconds. Go! Time's up. Drop your answers. The correct answer is C, multiplication. Let's proceed to question number 3. What is the value of the expression 2x squared minus 4 all over 2x plus 1 when we replace x by negative 3? These are the choices. A, 23 over 5. B, 6. C, negative 23 over 5. Or letter D, negative 6. 5 seconds. Go! Time's up. Drop your answers. The correct answer is letter C, negative 23 over 5. We can also use the concept of rational functions in current events. Let's have the local barangay receive a budget of 500,000 to provide the medical checkups for the children. The amount is to be allotted equally among all the children in the barangay. So we have f of x, the allotted amount per child, and x be the total number of children. Therefore, the function for this problem will be 500,000 pesos divided by the number of children, which is x. In order for us to understand further about the rational function, let us have its definition. Rational functions can be written in the form of f of x is equal to p of x over q of x, wherein p of x and q of x are polynomials, and q of x, take note of this, is not equal to 0. Here is an example of rational function. F of x is equal to x squared plus 2x plus 3 over x plus 1. As you notice, that the numerator is a polynomial, even the denominator. Let's have the domain and range of a rational function. Domain and range of a rational function is a set of all allowable values of x in a function. The domain of a rational function consists of all real numbers x except those for which the denominator is 0. The domain of a function f of x is a set of all values which the function is defined. The question is, how we can find the domain of a rational function? Here are the steps. Number 1, set the denominator equal to 0 and solve the resulting equation. Number 2, the domain is a set of all real numbers except the values obtained after solving the equation in step 1. Let us consider the following example. So f of x is equal to x minus 3 over x plus 2. Considering the definition of the domain, wherein all real numbers x except those which the denominator is 0. So we have f of x is equal to x minus 3 over x plus 2. Our main concern is the denominator, which is x plus 2 equating to 0. So we need to find any value of x that would make the denominator equal to 0. So using the addition property of equality, so you're going to add negative 2 on both sides. Wherein 2 plus negative 2 is equal to 0. So the resulting equation will be x is equal to negative 2. Therefore, the domain will be all real numbers except negative 2. We can obviously see that when we substitute negative 2 to the given function, the result will not be defined. Let's have another example. F of x is equal to x plus 7 over x squared plus 8x minus 9. Let's have the solution. So we have f of x is equal to x plus 7 over x squared plus 8x minus 9. We need to find any value of x that would make the denominator equal to 0 by setting the denominator, which is x squared plus 8x minus 9 is equal to 0. Solve the equation by factoring because this is a polynomial equation. So we have x plus 9 times the quantity x minus 1 is equal to 0. Performing the operations, we will have x is equal to negative 9 or x is equal to positive 1. So therefore, the domain will be all real numbers except negative 9 and positive 1. This time, let us talk about the range of irrational functions. The range is a set of all allowable values of y in a function. The range of a rational function consists of all real numbers y except those which the denominator is 0. Let's consider the following example. Same example just like when we find the domain of a rational function. So we have f of x is equal to x minus 3 over x plus 2. Let's have the solution. In order for us to solve this range, we'll have the following steps. Number 1, replace f of x by y. Switch the rules of x and y or interchange the positions of x and y. Then solve for y in terms of x. So let's use those steps. So we have f of x is equal to x minus 3 over x plus 2. Now, using the inverse function method, you're going to redefine x in terms of y. So from f of x, it will become y is equal to x minus 3 over x plus 2. And then interchange the positions of x and y. So therefore, this will become x is equal to y minus 3 over y plus 2. So multiplying both sides by y plus 2, so this will become x quantity y plus 2 is equal to y minus 3 over y plus 2 multiplied by quantity y plus 2. As you can see, we can eliminate y plus 2 from the numerator and the denominator. So the resulting equation will be x quantity y plus 2 is equal to y minus 3. Now, you're going to distribute x on the left side of the equation. So this will become xy plus 2x is equal to y minus 3. This time, we're going to combine similar terms, which are xy minus y is equal to negative 2x minus 3. So as you can see, the left side has a common variable, which is y. So this will become y quantity x minus 1 is equal to negative 2x minus 3. So we have y quantity x minus 1 is equal to negative 2x minus 3. Dividing both sides by x minus 1. So this will become y quantity x minus 1 all over x minus 1 is equal to negative 2x minus 3 all over x minus 1. So you can see, you can eliminate x minus 1. So this will be resulting into y raised to negative 1, or the inverse function of y is equal to negative 2x minus 3 all over x minus 1. Now, the main concern is, again, the denominator. So you're going to equate x minus 1 into 0. So this will become x is equal to 1. So the range of this rational equation will be all real numbers except positive 1. Let us now discuss the rational equation. What is a rational equation? Rational equation is an equation involving rational expressions which can be solved for all unknown values that satisfy the equation. Rational equation. This is one of the examples. So we have 2 over x minus 3 over 2x is equal to 1 over 5. Wherein the equation, wherein there will be a specific value for the given variable in the equation. How to solve rational equations? We have the following steps. So, number 1, multiply both sides by the LCD. Next, distribute the LCD to each term. Number 3, simplify and then solve. Let's have the first example. Solve 6 over x plus 5 over 4 is equal to negative 7 over 4. So multiplying by the LCD, which is 4x in every part of the equation, so we have 4x times the quantity 6 over x plus 4x times the quantity 5 over 4 is equal to 4x times the quantity negative 7 over 4. As you can see, we can cancel out the common factor between the numerator and the denominator. So the resulting equation will be 4 times the quantity 6 plus 5x is equal to negative 7x. Now, combining similar terms, which are 5x plus 7x, the result is negative 24. Now, performing the operation, so we have 5x plus 7x, that is 12x, is equal to negative 24. Dividing both sides by positive 12 to eliminate 12 on the other side, so we have x is equal to negative 2. So if you want to check if the value of x, which is negative 2, is the correct answer, let's have this one. So the solution will be the quantity 6 over negative 2 plus the quantity 5 over 4 is equal to negative 7 over 4 multiplied by the LCD, which is 4. Now, so this will become negative 3 times the quantity 4 plus 5 times 4 over 4 is equal to negative 7 times 4 over 4. So as you can see, negative 3 times 4 is negative 12. Then you can cancel out 4. So the result is 5 is equal to negative 7. So negative 12 plus 7 is equal to negative 7 is equal to negative 7. So it means the value of x, which is negative 2, is correct. This time, we will discuss the concept about rational inequalities. What are rational inequalities? A rational inequality is composed of rational expressions combined with the following symbols, which are less than, greater than, lesser or equal, or greater than or equal signs. For example, 5 over x minus 3 is less than or equal to 2 over x. This is an example of rational inequality. Let us now deal on how to solve a rational inequality. We have the following steps. Number 1, write the inequality in general form. Number 2, determine the critical points or critical values. How to find the critical points? By setting the numerator and the denominator equal to 0. Number 3, use the critical points to separate the number line into intervals. Number 4, test the critical points. How to test? If the critical points make the inequality true, then they are part of the solution. Otherwise, they are not part of the solution. Number 5, express the answers in interval notation. So let's have this example. Solve the inequality 1 over 2 or 1/2 plus 2 over x minus 1 is greater than or equal to 1. So the first step is to write into a single rational expression. So we have 1/2 plus 2 over x minus 1 greater than or equal to 1, which is the original inequality. So what you can see is by using the addition property of equality by adding -1 on both sides, so the result will be 1/2 plus 2 over x minus 1 minus 1 is greater than or equal to 0. Then 1/2 plus 2 over x minus 1 minus 1 is greater than or equal to 0. So using the LCD, which is 2 quantity x minus 1, so applying the LCD on all the rational inequality, so we will have 1 times the quantity x minus 1 plus 2 times 2 plus 1 times 2 times x minus 1 all over 2 times x minus 1, which is the LCD. So as you can see, you are going to distribute everything, okay, on the numerator. So we have 1 times x minus 1 plus 2 times 2 minus 1 times 2 times x, then 1 times 2 times x times -1. So the resulting rational inequality will have x minus 1 plus 4 minus 2x plus 2 all over 2 times the quantity x minus 1 is greater than or equal to 0. As you can see, we have similar terms, which are x and -2x. And even the constant, which are -1, +4, and +2. So the resulting rational inequality will be -x plus 5 all over 2 times the quantity x minus 1. As you can see, we have single rational inequality. Step 2, determine the critical points or critical values. The main concern will be the numerator and the denominator. As you can see, the numerator is -x plus 5 equal to 0. Therefore, x is equal to +5. Now, on the denominator, we have x minus 1 is equal to 0. So therefore, x is equal to +1. Number 3, use the critical points to separate the number line into an interval. So we have the number line, wherein x is equal to 1 will be located in this part, and x is equal to 5 will be located in this part. So on the left side of x is equal to 1 will be x is less than 1. Between x and 5 will be x is greater than 1 but less than 5. And beyond 5 will be x is greater than 5. Now let's test if x is equal to 2 in this part. So we have negative times -2 plus 5 all over 2 times the quantity -2 minus 1 is greater than or equal to 0. Performing the operation, so we'll have 2 plus 7 over 2 times the quantity -3 is greater than or equal to 0. So we'll have 7 over -6 is greater than or equal to 0. Is this true? No, it's false. Meaning, this is not part of the solution. So let's have between 1 and 5. Let's consider x is equal to 3. Using the single rational inequality that we have, so we have negative times 3 plus 5 all over 2 times the quantity 3 minus 1, it must be greater than or equal to 0. Now, performing the operation, so we come up with negative 3 plus 5 over 2 times 2. Is this greater than or equal to 0? Let's find out. This will become 2 over 4, or 2 over 4 is greater than or equal to 0, or 1/2 is greater than or equal to 0. The question is 1/2 greater than or equal to 0? Yes, it's true. Meaning, this point or this portion is part of the solution. Let's consider if x is equal to 6. Simply, again, substitute in the rational inequality. Negative times 6 plus 5 all over 2 times the quantity 6 minus 1. It must be greater than or equal to 0. Performing the operation, so we have negative 1 over 2 times 5. Greater than or equal to 0. So is negative 1 over 10 greater than or equal to 0? No, it's false. Again, if it's false, it's not part of the solution. So after testing those boundaries, let's test also the critical points, which are x is equal to 5, and x is equal to 1. Let's test if x is equal to 1. So negative times 1 plus 5 all over 2 times the quantity 1 minus 1 is greater than or equal to 0. Performing the operation, so we come up with 4 is equal to 2 times 0 greater than or equal to 0. So we have 4 over 0 is greater than or equal to 0. So as you can see, we have 0 on the denominator. So this means this is undefined. So if it's undefined, meaning it's not part of the solution. Now let's consider if x is equal to 5. So using the rational inequality, so we have negative 5 plus 5 all over 2 times the quantity 5 minus 1, it must be greater than or equal to 0. Performing the operation, so we have 0 over 2 times 4 is greater than or equal to 0. So again, is 0 over 8 greater than or equal to 0? Yes, it's true, because 0 is greater than or equal to 0. So meaning, x is equal to 5 will be included in the set of the solution. Now, number 4 step will be identifying the solution set. So from our previous solution, so this part will not be part of the solution, wherein x is less than 1. Now, in this portion, it's part of the solution since we come up with true statement. And this part still not part of the solution. And from the critical points, x is equal to 1 is not part of the solution since it will not satisfy the rational inequality, while the x is equal to 5 is part of the solution. So therefore, number 5, express the answer in interval notation. So, the interval x is greater than or equal to 1 and less than or equal to 5 will be the solution. So therefore, the solution set will be set of x an element of real numbers such that x is greater than 1 but less than or equal to 5. Can you still follow? Okay, so this time, these are the ways in representing rational functions. As you can see, we can use rational functions in some science problem. Let's find out. Let's have the average speed or velocity, which can be computed using the formula s is equal to d over t, wherein s represents the speed, d for the distance, and t is for the time. Can be expressed in the form of rational function. Let's have this example. A rational function in equation form. Suppose you run in a marathon. How would you represent the time it takes for you to run in 100 meters in a track? Let's have the solution. Let t represent the time it takes for you to run in 100 meters. Then the speed can be represented as a function s of t. So therefore, s of t is equal to d over time. Since a distance of 100 is given, therefore, the rational function will be S of t is equal to 100 over t. Now, we can also represent rational functions as table of values. Okay, using the first example, the next step is to construct a table of values for you to represent or to find out the speed against the given different runtimes. So as you can see, we have the table wherein t represents the runtimes, which will be 10 seconds, 12 seconds, 14 seconds, 16 seconds, 18 seconds, until 20 seconds. So using the rational function S of t is equal to 100 over t, the table of values for runtime from 10 to 20 seconds is as follows. So if your runtime is 10 seconds, so the speed will be 10. If your runtime will be 12, the speed will be 8.33. If your runtime will be 14, the speed will be 7.14. And if your runtime will be 16 seconds, the speed will be 6.25. And if your runtime will be 18 seconds, the speed will be 5.56. And lastly, if your runtime will be 20 seconds, the speed will be 5. Okay, after computing the runtime from 10 to 20 seconds, we want to interpret the data using the graph, which is letter C, rational function as a graph. So the graph can be used to check if the points on the function shows or follows a smooth curve or a straight line. So as you can see, if you're going to graph those data in the second example, okay, from the first question, so we have this smooth curve. So as you can see, as the time gets higher and higher from 10 seconds to 20 seconds, the speed gets lower. So thank you for allowing me to share this week number 2 for this discussion. Thank you also for staying until this far. This time, let us cater some of your concerns and questions about the previous discussions. So I think we don't have any question. If you do, reserve it and let your subject teacher discuss it during your follow-up discussion to be discussed on tomorrow, I think. So before we end, here are your assignments. Please answer the following portion in your module, page 11, wherein you're going to answer what I have learned, what I can do, and the assessment portion. So in this case, this has been your live streaming teacher. I'm Mr. Sitialgo from Malinta National High School, saying keep on studying because a good education is a foundation for a better future. Stay safe and God bless.